Excavation is one of the most hazardous types of work done in the construction industry. Excavation accidents occur frequently and tend to be more serious than construction accidents in general. The primary type of accident of concern in excavation-related work is a cave-in. The actual number of cave-in accidents is not large when compared to the total number of accidents occurring in all of construction. However, those that do occur tend to be of a very serious nature. The National Institute of Occupational Safety and Health, NIOSH, conducts research on various safety and health problems, provides technical assistance to OSHA, and recommends standards for OSHA's adoption. In a recent report prepared by NIOSH based on OSHA's inspection data, it was estimated that at least 73 persons were killed each year in cave-in accidents, and at least 97 persons were killed as a result of all excavation-related accidents. This program presents an overview of OSHA's requirements for protection of employees in excavations. OSHA's excavation standard is contained in its Code of Federal Regulations for the Construction Industry, 29 CFR, Part 1926. The standards found in Subpart P consist of 3 sections. Section 1926-650 contains the scope, application, and definitions applicable to Subpart P. Section 1926-651 contains general requirements, and Section 1926-652 contains requirements for protective systems. There are also 6 appendices, A through F. OSHA's excavation standard defines excavations to include trenches. The standard states that, in general, the depth of a trench is greater than the width, but the width of the trench, measured at the bottom, is not greater than 15 feet. OSHA Standard 29 CFR 1926-651 contains requirements for the protection of employees against several different types of hazards of excavation-related work. Let's look at some of these. All surface encumbrances, such as trees or boulders, that are located so as to create a hazard must be removed or supported to safeguard workers. The estimated location of utility installations such as sewer, water, fuel, and electric lines, or any other underground installations that may reasonably be met with during excavation work, are to be determined prior to opening the ground. Prior to start of actual operations, the utility companies or owners are to be advised of the proposed work and asked to establish the underground installation's actual location. When the utility or owner cannot establish exact locations or respond in a timely manner, the contractor may proceed with caution. Detection equipment or other acceptable means to locate utility installations must be used. When excavation work nears the estimated location of the installations, the exact location is to be found by safe and acceptable means. While the excavation is open, underground installations must be protected, supported, or removed as necessary to safeguard employees. Flooding, shock, asphyxiation, electrocution, fire, explosion, and collapse of undermined installations are some of the hazards that result when underground installations are damaged. Structural ramps must be designed and constructed to meet the requirements of their usage. Safe means of entering and leaving excavations must be provided for workers. A stairway, ladder, ramp, or other safe means of egress must be located in trench excavations 4 feet or more in depth so as to require no more than 25 feet of lateral travel. This is to allow workers to get out quickly in the event of an emergency. Employees exposed to public vehicular traffic shall be provided with and must wear warning vests or other suitable garments marked with or made of reflectorized or high visibility material. Employees are not allowed under loads handled by lifting or digging equipment. Employees must stand away from vehicles being loaded or unloaded to avoid being struck by spillage or falling materials. Operators may remain in the cabs of vehicles being loaded or unloaded when the vehicles are equipped to provide adequate protection for the operator during these operations. When mobile equipment is operated next to an excavation or when it must approach the edge of an excavation and the operator does not have a clear, direct view of the edge, a warning system must be used. This system may involve barricades, stop logs, or signals. To prevent exposure to harmful levels of air contaminants and to assure acceptable atmospheric conditions, certain requirements must be met. Under certain conditions, atmospheres of excavations greater than 4 feet deep must be tested before employees may enter. Testing is required where oxygen deficiency, that is less than 19.5% oxygen, or a hazardous atmosphere exists or could reasonably be expected to exist. Examples of these conditions include excavations in landfill areas or where hazardous substances are stored nearby, or where underground installations may have been ruptured. Adequate precautions shall be taken to prevent employee exposure to atmospheres containing less than 19.5% oxygen and other hazardous atmospheres. These precautions include providing proper respiratory protection or ventilation. When controls such as ventilation are used to reduce the level of atmospheric contaminants to an acceptable level, testing is to be conducted as often as necessary to ensure continuing safety. Emergency rescue equipment such as breathing apparatus, a safety harness and line, or a basket stretcher must be readily available where hazardous atmospheric conditions exist or can reasonably be expected to develop. This equipment must be attended when in use. Employees entering deep and confined footing excavations are to wear a harness with a securely attached lifeline. The lifeline is to be separate from any line used to handle materials and is to be individually attended at all times while the employee wearing the lifeline is in the excavation. Water is very likely to be present during the course of work in many excavations and is one of the major concerns during excavation operations. The action of water against the sides of excavations can cause undermining and cave-ins. The presence of accumulated water in or around excavations must, therefore, be treated with caution. Employees shall not be permitted to work in excavations where water has accumulated or is accumulating unless adequate precautions have been taken to protect them. Necessary precautions vary with each situation but could include special support or shield systems or water removal. If water removal equipment is used, the equipment and its operation must be monitored by a competent person to assure continued proper operation. If excavation work interrupts the natural drainage of surface water, diversion ditches, dikes, or other means must be used to prevent surface water from entering the excavation and to provide safe drainage of the adjacent area. Workers may also face hazards where the stability of adjacent buildings, walls, or other structures is endangered by excavation operations. Support systems such as shoring, bracing, or underpinning must be provided to ensure the stability of such structures for the protection of employees. Excavation below the level of the base or footing of any foundation or retaining wall that could be reasonably expected to pose a hazard to employees is not permitted except when the excavation is entirely in stable rock or a support system such as underpinning is provided to ensure employee safety and stability of the structure, or a registered professional engineer, PE, has approved a determination that the structure is far enough away not to be affected by excavation activity, or that such excavation work will not pose a hazard to employees. Sidewalks, pavements, and a pertinent structure may not be undermined unless a support system or another method of protection is provided to protect employees from possible collapse. Employees must be protected from loose rock or soil which might create a hazard by falling or rolling from the excavation face. Materials and/or machines may become hazardous if measures aren't taken to keep them from sliding or falling into an excavation where employees are working. Protection of employees from materials or equipment which could fall or roll into an excavation shall be provided by keeping them at least 2 feet from the edge of excavations, or by the use of adequate retaining devices, or by a combination of both if necessary. Daily inspections of excavations, the adjacent areas, and protective systems must be made by a competent person for evidence of a situation that could result in possible cave-ins, failure of protective systems, hazardous atmospheres, or other hazardous conditions. Excavations subject to heavy rain runoff are to be inspected by a competent person and, as necessary, precautions instituted to protect against the hazard. Inspection shall be made after every rainstorm or other hazard-increasing occurrence. The competent person shall make inspections prior to the start of work and as needed throughout the shift, as well as after every rainstorm or other hazard-increasing occurrence. These inspections are only required when employee exposure can be reasonably anticipated. Where employees or equipment are required or permitted to cross over excavations, walkways or bridges with standard guardrails must be provided. Excavation safety requires pre-planning. Let's take a look at some other areas where anticipation of possible hazards can help avoid accidents and injuries. OSHA Standard 29 CFR 1926-652 contains requirements for the protection of employees from cave-ins through the use of protective systems. OSHA requires that each employee in an excavation be protected from cave-ins by a protective system except when excavations are made entirely in stable rock or excavations are less than 5 feet in depth and determined by a competent person to show no indication of potential cave-in. OSHA divides protective systems into two categories: sloping and benching systems and support systems, shield systems, and other protective systems. The use of either of these categories of protective systems requires the choice of one of 4 design options. Let's first look at the allowable options when choosing sloping and benching systems. The options include allowable configurations and slopes, the use of appendices A and B, designs using other tabulated data, and designed by a registered professional engineer. The first option specifies allowable configurations and slopes. Any excavation less than 20 feet in depth may be sloped at an angle not steeper than 1 1/2 horizontal to 1 vertical, 34 degrees measured from the horizontal. Such slopes meet OSHA's requirements for worst-case soils, Type C, as defined in 29 CFR 1926, Subpart P, Appendix A. The second option involves the use of appendices A and B. Maximum allowable slopes and allowable configurations for sloping and benching systems are set forth in appendices A and B. The third option, when choosing sloping and benching systems, involves the use of tabulated data, such as tables and charts. The tabulated data must be in written form and include selection criteria, limits on data usage to include the magnitude and configuration of slopes determined to be safe, explanatory information necessary to aid the user to make correct selection of protective systems, and the identity of the registered PE who approved the data. At least one copy of this data must be kept at the job site during construction of the protective system. The fourth option involves the design by a registered professional engineer. Designs must be in written form and must include the magnitudes and configurations of slopes and benches determined to be safe for the project, as well as the identity of the approving PE. The second category of protective system prescribed by OSHA to protect employees from cave-ins involves the use of support systems, shield systems, and other protective systems. The use of this category also requires the choice of one of 4 design options. The first option is to use appendices A and C or D. For timber shoring and trenches, Appendix A, soil classification, and Appendix C, timber shoring, are to be used. Hydraulic shoring of trenches calls for use of either Option 2, manufacturer's tabulated data, or Appendix D, aluminum hydraulic shoring. Appendix D is to be used when manufacturer's tabulated data are not available. The second option is to use manufacturer's tabulated data. Design of support, shield, or other protective systems using these data must agree with all specifications, recommendations, and the limitations issued or made by the manufacturer. Deviations are allowed only with the manufacturer's specific written approval. These data are to be in written form and kept at the job site during construction of the protective system. The third option when choosing the use of support, shield, or other protective systems is design using other tabulated data. The contractor may select from designs in agreement with tabulated data, such as tables and charts approved by a registered professional engineer. The written data are to be kept at the job site during construction of the protective system and shall include the parameters that affect system selection, the limits of data usage, and any explanatory information necessary to make the correct system selection. The fourth option is to use a design approved by a registered professional engineer. Such designs are to be written, kept at the job site during construction of the protective system, and include a plan indicating the size, types, and configuration of the materials to be used, and the identity of the approving registered PE. Materials and equipment used for protective systems must be free from damage or defects that might impair their proper function. A competent person shall examine damaged material or equipment to evaluate its suitability for continued use. Material or equipment found unsafe for continued use shall be removed from service. Members of support systems are to be securely connected to prevent sliding, falling, kickouts, or other predictable failures. Support systems must be installed and removed in a way which protects employees from cave-ins, structural collapses, or from being struck by system members. Installation should begin at the top and progress to the bottom of the excavation. Removal reverses this process. Installation of support systems is to be closely coordinated with the excavation of trenches. Backfilling shall progress together with the removal of support systems. Material may be dug to a level no more than 2 feet below the bottom members of a support system if the system is designed to resist the forces calculated to the full depth of the trench, and there is no indication of soil loss from behind or below the bottom of the support system. This allowance for 2 free feet also applies to trench shields. Employees may not work on the faces of slopes or benches above other workers unless the workers at the lower level are protected from the hazard of falling, rolling, or sliding material or equipment. Shields shall be installed in a way that will restrict lateral or other hazardous movement of the shield in the event of sudden lateral pressures. Employees are not to be in shields when they are being installed, removed, or moved vertically. Employees may remain inside shields being moved horizontally. Employees are also to be protected from the hazards of cave-ins when they're entering or leaving the areas protected by the shield. Contractors who choose to use the appendices of OSHA's excavation standard in design and construction of a protective system must thereafter treat the provisions of the selected appendices as mandatory. Appendix A describes a method of classifying soil and rock deposits based on site and environmental conditions and on the structure and composition of the earth deposits. The appendix contains definitions, sets forth requirements, and describes acceptable visual and manual tests for use in classifying soils. This appendix applies when a sloping or benching system designed in accordance with the requirements of 1926 652B2 is chosen, when timber shoring for excavations is designed in accordance with Appendix C of Subpart P, or when aluminum hydraulic shoring is designed in accordance with Appendix D. Appendix A also applies if other protective systems are designed and selected for use from data prepared in accordance with requirements set forth in 1926 652C, and the use of the data is based on use of the soil classification system presented in Appendix A. To restate, use of Appendix B, sloping and benching, Appendix C, timber shoring for trenches, or Appendix D, aluminum hydraulic shoring for trenches, all require the use of Appendix A, soil classification. Indeed, Any protective system based on the use of the soil classification system presented in Appendix A must meet all the requirements of that appendix. Appendix B contains specifications for sloping and benching when used to protect employees from cave-ins. Maximum allowable slopes and benches are based on the soil types as classified in Appendix A and are found in tables B1 through B14. Appendix C contains information to be used when timber shoring is provided as a method of protection from cave-ins in trenches not more than 20 feet deep. Selection of required timber dimensions and placement may be found in tables C11 through C23. Each table presents the minimum sizes of timber members to use in a shoring system. Tables C11 through C13 are for actual size. Tables C21 through C23 are for nominal size. Appendix D sets forth requirements for aluminum hydraulic shoring in trenches less than 20 feet deep. This appendix must be used when manufacturers' tabulated data are not available. Required sizes and placement of hydraulic shoring are given in tables D11 through D14. Appendix E illustrates alternatives to timber shoring such as aluminum hydraulic shoring, pneumatic hydraulic shoring, trench jacks, and trench shields. Appendix F presents a graphic summary of the requirements and options in Subpart P for excavations 20 feet or less in depth. Deeper excavations require protective systems designed by a registered professional engineer or manufactured systems capable of the needed depth and used in accordance with manufacturer specifications. This program has presented an overview of OSHA's requirements for protection of employees in excavations. Strict adherence to these regulations can substantially reduce the number and severity of accidents resulting from excavation work. If you would like more information about OSHA or about how to comply with OSHA excavation regulations, contact your nearest OSHA area office.